Hello, kiddos. I am so sorry. I was having some technical difficulties this morning. Just right here. There was some technical difficulties with my internet, so I had to get all that taken care of, and it just got worked out and had to do some other things. But I'm going to go ahead and give you guys chapter number 9 today. This is what's going to be on the video, and I'm going to upload it. So I'm going to go through chapter 9, and then your exam is going to be Wednesday on chapters 7, 8, 9, and 10. No, we did 9 already. I'm doing chapter 10 today. Excuse me, I'm sorry about that. This internet thing kind of just made me crazy today. So I'm doing chapter 10. Your test is going to be over those 4 chapters, 7, 8, 9, and 10. Expect about maybe around about 60 to 75 questions. You're going to have 80 minutes to do it, or pretty much 80 minutes. So however much amount of time we have in class is what you're going to do. But I'm going to go ahead and do chapter 10, and then I'm going to upload it for you guys, and I will talk to you guys later. I am so sorry. I didn't know that I was going to have all these technical difficulties this morning. Hey Taylor, I'm going to go ahead and do chapter number 10, and you guys going to have your test on Wednesday on chapters 7, 8, 9, and 10. All right, I'm going to turn my camera off, and let me share screen with you guys. Chapter 10, share, and that coming up. And I am going to stop my video. And then we're going to look at chapter number 10 today. This is the last chapter we're going to do before we have our exam. Because we're in this particular format, I think it'll be easier for me to actually cover more chapters and cover the whole book. So chapters that I don't get to, and what I'm going to do is look at and see if I can get to all the chapters in the book. But I'm pretty sure we probably won't get to all the chapters, but what I'm going to do is pre-record the last few chapters so that you guys can have those and view those on your own. Okay, chapter number 10, and I'm going to try to get as far as I can because I do have another class at 9:30. We're looking at matter, light, and glass examination, and actually right up under me, I have something. Hello, can you mute your mic? Okay, I'm just trying to make sure. Can you mute your mic? And everything. So with chapter 10, we're going to look at everything else at the crime scene. We looked at bullets. We'd have talked about the bodies, but what about where we find all of this other evidence? Light, how proper lighting help, all of that stuff. So that's what we're going to look at. Now, what we have to look at is physical properties versus chemical properties. So we have to look at matter. So when it comes to forensic science and criminalistics, chemistry actually plays a huge part in all of this. So that is something that we really do have to look at. So characteristics to matter give it unique identity. We have to also look at, boiling point, melting point, um, other substances, color. Um, we have to take all of that into account too, because um, that can have a bearing on the evidence itself. Now, when we talk about chemical properties, we talk about the behavior of a substance when it reacts or combines with other substances. So we're gonna look at physical versus chemical. Now, when we talk about this, just to give you a little bit background on the chemistry itself. And chemistry looks at basic down to what is an element, and we look at what we talk about is the periodic table. The element is the simplest building block um, known to the substance. So everything is made up of matter, and it has an element to it. So matter is anything that has mass and take up space. And all elements on the periodic table, they're listed by name and they're listed by symbol. When you have two or more elements, like for example, water. Water is a combination of hydrogen and oxygen, and water is also a compound. It's also considered a pure substance too, but it's a compound because it's made up of two or more elements. So, and then when you talk about that, the atom is the basic particle of the element, and the molecule is the smallest unit of the compound. So H2O is the smallest molecule, is the molecule that makes up water. That's the compound, and this is the smallest molecule. Now, matter itself can be classified according to the physical form that it takes. You got solids, you have liquids, and you have gases. So solids defined is a definite shape and a definite volume. Now, when you have something that is liquid, it takes on the shape of the container. And then when you have gas or vapor, it doesn't have a definite shape nor the volume, which means, and this is what I tell my chemistry classes. For example, you have a bottle of water, and I can show that to you. If you have that bottle of water, that bottle of water can take on the shape and the shape of that actual container is in that water bottle. Now, when it comes to the let's just say the size of a room, we all breathe in air, and so when it comes to the size of a room, we have to look at and take on the gas in that room, the air. It takes on the shape of the room, and it takes on that size of the room, so the volume of it. So how much air is in the room is the size of the room itself. So that's when you look at it when you talk about gases. Um, this is an example of the periodic table. When this book was printed a couple of years ago, and I just got the new version of this book. This book they had named all of the elements on the periodic table. They discovered them, but they hadn't all been named. And so now what you're looking at is some of the old names, but elements 115 through 118 have been they have been given their names already. And so I think when they printed this, 116 had their name, but they had named 115, 117, and 118. And I tell people all the time, one of my goals in life is to put an element on the periodic table. That's one of my dreams. That's what I want to do. So chemistry is really one of my passions. I really love that. Now, let's talk about looking at basically when we talk about substances. They can change from one phase to another without forming a new chemical species. The matter is simply being changed from one physical state to another. Um, Whenever this exists, in which a substance can distinguish by a visible boundary, you can have different phases of a material. So you have water. Water can be in the form of a solid, a liquid, or a gas. When you boil water, for example, you heat it up and you see the steam coming off of that. That's one phase. Then when you drink water, it's in the liquid phase. And then, of course, if you like your beverages cold like I do, um, you like to drink cold beverages, you like a little bit of ice in it. So that's the solid phase. So water is just one of those examples. Everybody know it, everybody see it, they touch it. I mean, whether you're boiling noodles or drinking water or you want ice in your beverage, that's what it is, and that's just an easy example that everybody see every day. So we as scientists, and I say that because I am a scientist, we look at different things, and one of the things that we like to look at is using different types of measurements. One of those measurements being the metric system. So with the metric system, it has basic units of length, mass, um, volume, and then in the lab itself, what I like to use is meters, grams, centimeters, all of that stuff. Now, there are common prefixes that we use. Right now, we use gigabytes because, like I said, the company with my internet. So we use centi, deci, mega, nano, um, which, you know, for my research when I was working on my PhD, I did a lot of work in material science, but we looked at stuff on the nanoscale. And nanoscale is just a size up from the atom. Because when we look at atoms and look at elements, they're on a scale called the angstrom. And the angstrom is just an order of magnitude lower than the nanometer. So these are two different measurements that we use. Deci, centi, these are the common prefixes that you see. Measurements, length, mass, volume, those are very common. Now, one of the things I like to tell my students, milliliters and centimeters cubed, or the cc, as if you got somebody that is I like to say an old school nurse, they like to say cc's, but nowadays we deal in milliliters, and so we have both of those, and so this is what we actually use. So 1 centimeter cube or 1 cc is the same as 1 milliliter. So I know a lot of people be like, what, huh? But that's really what it is. Now, we use metric, and some people use English. And so what it is, we have two different scales that we see and that we use for that. And so we use both of those. We use all of those. So we use metric, and usually I try to have rulers that have both on there because I never know who's familiar with what. Now, physical properties. When we talk about physical properties, um, we talk about stuff such as um, temperature. Temperature is the measure of heat intensity. When we're looking at temperature, when it comes to criminal evidence, how long the body been dead. Um, Given the body temp, they can tell you approximately time of death. Um, So temperature is one. So in science, we use the Celsius scale, and the Celsius scale deals with water. So in chemistry, and I tell my students, there are three different scales we deal with. We deal with Fahrenheit, and Fahrenheit deals with the human body. Um, then we deal with Celsius. Celsius deals with water. And then we have what we call the absolute scale, or called Kelvin, and Kelvin deals with gases. So those are the three scales, but one of the ones we use mostly, and everybody uses across the world, except for the United States, most of the time, unless you're in a classroom, is the Celsius scale. So everybody uses that. Now, there's a difference between weight and mass. Mass refers to how much matter an object contains, independent of gravity. Weight is, okay, the force in which gravity attracts a body. So the mass that you have here on Earth is the same as the mass that you will have on the moon, but your weight is going to be different because the force of gravity on the moon make you feel lighter than the force of gravity that is here on the Earth. And so that's the difference between the two. Now, I told you there were three scales. Then we have the Celsius and the Fahrenheit scales, and these are just the differences right here. So this is what you see. You see the measurement of mass that is going on right here. So this is technically what you're seeing. And then we have this thing called density. Now, density is defined as mass over volume, M over V. And I like to write it small m over big V. Now, density is an intensive property, meaning that it remains the same regardless of the size. Now, it is a characteristic property that they use in identification. So, mass is very important. So what they do is, and too bad we're not at school, but I can demonstrate to you that, let's just say, and I don't have a scale here. That's my thing. I don't have a scale. Usually I would have a food scale, but I don't think I have one in my kitchen. I might pick one up today. For determining the density of a solid, you have to measure the mass first and then measure its volume. I do, however, have a couple of graduate cylinders. So I will shoot a small video demonstrating that to measure mass and doing density. So we can do that, mass over volume. And then here they just show you how to do the calculations to get your density. This is measured in grams per milliliter. So this is a good way. So one of the things we can do is, and I can show you is how to do the density of a penny. Now, we done talked about that part. Let's switch gears and talk about refractive index, because in the previous chapter, we actually talked about not only refractive index, but we talked about microscopes and stuff, and this is one of the things we really alluded to. So with that being said, the bending of light because of a change in velocity, it is called refraction. And so light waves, they travel in air, and they travel at a constant velocity until they penetrate another medium, such as glass, water, and then they slow down. And when they slow down, they slowing down because they have to bend going through those mediums. So we have refractive index. So the refractive index is really defined as the ratio of velocity of light in a vacuum to that in a medium under examination. So they have to run it compare it against something. So usually they compare it in vacuum compared to it being in the medium. So let's just say if you look at a ball and you got this figure here, it's traveled obliquely from one medium to another. And so the ball is in the water, but what you're looking at is, it may look like it's on the bottom, but it's actually still sitting right there. So if you're looking at something like a foam ball or something that is floating in the air. Now, crystalline solids, however, will have different types of shapes and forms and all of that. So when you see those, you actually get a sense of the order of arrangements when it comes to the elements or the atoms in an element or in a compound. So when you do that, you actually see all of that. Now, solids themselves refract different types of beams and everything. And so when you see all of that, you can see in two different ways of components, and this results in double refraction. So you can have that, and that can actually happen. Now, birefringence is the numerical differences between those two refractive indices. Not all solids are crystalline in nature. Glass has a random arrangement because we call that amorphous, and it forms amorphous or non-crystalline solid. Now, what it is, for example, at 25 degrees Celsius, the refractive index of water is 1.33. That means that it travels 1.333 times faster in a vacuum than it does in water. And then light density, the refractive index is an intensive property. And it will serve to characterize a substance. So they do that as well. Now, there are two models that describe light. Now, and what I tell my students, it's not two models, it is what it is. Light, or we like to call it electromagnetic radiation, has what we call a dual nature, meaning that it acts as a wave and it acts as a particle. So we call it duality of light. That's what we like to use, or call it dual nature. When light passes through the prism, it disperses into this continuous spectrum of all these different colors. Now, visible light ranges its color from red to violet on what we call the electromagnetic spectrum. Waves are described in terms of wavelength, frequency, and so wavelength is the distance between two crests or trough to trough. And then frequency is the number of crests passing through one given point. And so right here, this is a representation of the dispersion of light in a glass prism. Now, frequency and wavelength, they're inversely proportional to one another, but there's another thing that's in there, and we call that the speed of light, and it's coming in there. The electromagnetic spectrum is the entire range of radiation for the cosmic rays, and visible light is the only small part of the electromagnetic radiation. Now, as it moves through space, this radiation acts as a continuous wave. However, once the radiation is absorbed by the substance, it's best described as a discrete particles of light known as photons. And to break that down to you, basically what happens is